I'm going to move to introducing now our morning keynote speaker. And Daniel Theobald is an expert in robotics. He has decades of experience leading scientists and teams of engineers in developing these technologies. He has 67 issued patents and 30 patents pending. He's got a very impressive academic record at MIT and has received a prestigious Hertz Foundation Fellowship. In 2018, he founded Vecna Robotics, now a global leader in autonomous forklifts. In 2014, he co-founded MassRobotics, a nonprofit dedicated to the global advancement of the robotics industry. We came to know Daniel by way of our colleagues from UC Santa Cruz and an introduction to his passion project, which is now turning towards agricultural mechanization at Twisted Fields Research Farm on the coast north of Santa Cruz. He's got an impressive resume and background, and really he's got a mind that I've been impressed with listening to and the way that he approaches the work that he's doing. And I look forward to hearing what Daniel has to say on the subjects that he's going to talk with us about this morning. Daniel. So you can take that off and walk around or stand here or do whatever you want. This thing works for the clicker, I believe.
All right.
Okay.
Thank you. It's great to be here today. I was just talking to my friend on the way down here about, there's so many things I've done through my career, but looking back on them, a lot of them I didn't really have the kind of passion that I have found around agriculture and farming and producing food. But I'm going to talk a little bit about some of the different companies and technology, and a little bit about what it's like being an entrepreneur and starting companies. But the number one thing I want to emphasize probably throughout the talk is the importance of collaboration and working together. That's what this is all about, and I think really where all the magic happens. So I appreciate the organizers putting this conference together and in giving us a venue to make those connections. So I was incredibly fortunate to be born where I was, when I was, all the things. I didn't really appreciate it at the time. I was born in San Jose, not too far from here, and was incredibly fortunate. I went to one of the first elementary schools in the world that had a computer lab, Laneview Elementary. We had Commodore PET computers and Apple I's. I thought this was just normal, right? It was just my life as a kid, and I thought this was happening everywhere all over the world. Had programming and electronics classes, elementary school, middle school, high school. Was incredibly fortunate to be chosen as the representative for the entire state of California in a supercomputing program back in the 80s, where I got to go to Lawrence Livermore National Lab, excuse me, and work on the world's fastest supercomputer at the time. It was called Bubbles because the entire computer was submerged in water to cool it, and worked on AI algorithms on this computer as a high school student, and got to spend some time with Edward Teller. If any of you know who Edward Teller is, very historical figure, father of the hydrogen bomb, and speaking with him really had a big impact on me, just in terms of thinking about how we as engineers can have a massive impact on the future of humanity, and the responsibility that we have to to be thoughtful about the things we do and how they're going to affect the world. So just here's some of the companies that I'm actively involved in right now. Josh mentioned them, MassRobotics. Interestingly, so I founded Vecna a long time ago as Vecna Technologies originally, and then we split it out when we brought in funding. And that's actually when I split out Twisted Fields. But Vecna Robotics, or Vecna Technologies at the time, started from day one with this idea that we were going to give back. And you know, there's a lot of people, I think, that feel like once I make it, then I'll start giving back. Once, you know, I'm a billionaire, then I can start the Gates Foundation or whatever. But we had this thought that we should really give back from day one. It should be part of the culture from the very beginning in every company. So we had a program where we paid our employees, it was a benefit, we paid our employees to spend 10% of every work week doing community service. It's interesting because I was actually friends with Clayton Christensen at Harvard Business School, so he's the disruptive technology guy. And I got all this pushback from both MIT Sloan Business School and Harvard Business School. You can't run a company that way. You know, you can't do community service like that. You'll be giving away all your profits. And I thought, well, maybe that's true, but I think it's the right thing to do, and we're going to do it. And they couldn't have been more wrong for so many reasons. It created a number of really beneficial feedback cycles in the company that I think really contributed to our success in two ways, really. One is that the type of people who would come work for us were the type of people who cared about giving back. And this created sort of a self-filtering mechanism where we got these incredible employees who are team players, you know, cared about making the world a better place, working hard. And what we found is that people who think of themselves as the type of people to give back really make the best employees. And so we were able to just accomplish incredible things. And then the other thing is we just made a huge difference in the world. It built an esprit de corps, right? Our team spirit was off the charts because everybody felt really good about what the company was doing and what it was accomplishing. We had everything from, you know, people building houses and Habitat for Humanity, working in soup kitchens, a lot of mentoring and tutoring. We did a lot of first robotics competitions. But as part of that, me and a couple colleagues realized that there was a real gap in the early robotics industry. We had struggled and struggled as a company to start. Being a robotics company is hard. And so we decided that we were going to use our community service hours to fund, to start an industry organization called MassRobotics. And MassRobotics is about the mass adoption of robotics. But it was something that has really paid dividends. So won't bore you with this, but so Vecna Robotics is the world leader in autonomous forklifts and tuggers. So this is just an example of a tugger. This is a FedEx facility where they use these, you know, formerly human-driven vehicles to carry your packages around from truck to truck. You know, got to get them from one side of the facility to the other. They mostly use conveyors for smaller things, but then they've got these bigger, more awkward items called non-conveyables that they'll often use these tuggers for. The next one is the forklift, autonomous forklift, exactly like you'd expect. One of the big innovations that we brought to the field early on was this idea of humans and robots working together. We've always had this thought that robots shouldn't replace humans. Robots should empower humans. Robots should make humans able to do more, do it safer, more enjoyable, right? It's about empowering humanity to accomplish more. And, you know, we've seen this pattern, of course, in farming. It used to be that it took 73% of our population to grow the food we eat. You know, that was not even 100 years ago. Now I think the latest statistics around 2%. So what does that do? That allows us to do other things like art, education, space exploration, science, caring for people. You know, I really don't like it when people try and pit automation against humans and, you know, automation versus jobs. It never actually has been that. If you actually look at the history of the world, automation has almost entirely created opportunities, empowered people, leveled the playing field. So this has been a real focus of ours from the beginning. The other big innovation we did was this idea that robots aren't going to be perfect. Humans aren't perfect. And when you hire a worker, that worker, you don't expect them to just magically know everything to do without a supervisor. They're going to have questions. Same thing for robots. So we pioneered this approach where the robots could ask for help of a human operator when they needed it. And it's interesting because early on we got tons of pushback from the academic community. You know, this was before there was wide adoption of robotics. Huge pushback about, well, if your robots actually worked, then you wouldn't need, you know, a human to be able to intervene and help it. Which of course now everybody has realized is absolutely absurd, and every single successful robotic company out there has used this model of the robot you know, has the ability to get help when it needs it. And so again, that's this ongoing theme in everything we do. My slide's not advancing. Of humans and technology working together. Maybe page down. Where's the page down? Need technical support here.
I think maybe go down here. We've got this book.
Yeah,
Well,
it's repeating.
just go like that. Go like that. Come down. Start there.
Yep, right there. Perfect.
There you go.
Technology, right? So this idea that technology should be used to help people. So I mentioned a little bit about MassRobotics. It's one of the fastest growing robotics industry associations in the world right now. It has three main missions. One, we knew how hard it was for engineers coming out of school to actually choose the right problems to solve. I couldn't tell you how many times I saw this. You know, they'd build some cool robot that had very little actual practical use in industry. And so we decided that one of the really important things was really connecting those brilliant roboticists, engineers coming out of schools like MIT, Stanford, Harvard, et cetera, and connecting them with the end users that actually needed that technology so that they could solve real problems. The other big problem, of course, that we have, particularly in this country, is just getting people interested in engineering. I'm not particularly nationalistic, but you know, this country is really getting left behind when it comes to technology education by a factor of like 10x or more. So we found that robotics is a phenomenal way to inspire young people. And one of the things I'm really proud about with MassRobotics is this focus on really helping young women to get excited about engineering, science, technology, and being able to explore opportunities in that area. I was going to a board meeting at MassRobotics. It's in Boston, and accidentally walked into the wrong room, and this entire room was filled with middle school young women who just were having the time of their life building robots. And we've just had some really heartwarming stories about that changing their entire life's trajectory. And so that's the kind of things that I think we get really excited about. And then the third one is really to help the industry move forward through standards, through de facto standards, but also formal standards. And just to talk briefly about this, AMR stands for Autonomous Mobile Robot. We realized that the industry was being hampered by the fact that every different robotic vendor was putting out robots, you know, that are completely proprietary, didn't talk to each other. And, you know, that'd be like hiring a whole bunch of employees that all spoke different languages and couldn't communicate with each other, right? It's going to be kind of a mess, a little bit of chaos. So we used the prestige and international pull of MassRobotics to develop this interoperability standard. And I really took a lot of inspiration from the integrated circuit industry. So I was at this talk at MIT, and an executive from Intel was there, and he said, you know, there's this thing called Moore's Law. So Moore's Law was the idea that about every 18 months to 2 years, the number of transistors on a piece of silicon could be doubled. What does that mean? That means computers get exponentially more powerful over time. And I had always heard about Moore's Law and, you know, just kind of thought like, oh yes, this is a law of physics. You know, this is just inevitable. It's like gravity. I drop this thing, or I let go of this thing and it's going to fall to the ground. He said, no, this was not a law of physics. This was a goal that we set as an industry, and only through working together as an industry in what he called pre-competitive collaboration were we able to continue to achieve this goal of, year after year, 2 year after 2 year doubling of the number of transistors on a chip. And so this idea of working together really stuck with me. Pre-competitive collaboration is something that has wide-reaching benefits. It's been challenging in the robotics industry, particularly because, again, as this emerging industry comes out of academia and lots of patents, and everybody thinks, oh, we're going to be the company that's going to own it all. People can be less likely to collaborate, less likely to share information. And this is what I think hampers the industry from moving forward. One of the things that we all need to realize is that there is trillions and trillions of dollars out there to be made, if money was your focus. Trillions. It's not like any one company or individual is going to, own all of this. But by working together, we can unlock benefit that we just can't do otherwise. So I really try and encourage this idea of working together. So a little bit about our research farm. It was introduced as a passion project. That's absolutely true. Honestly, don't tell anyone, but I don't really care about forklifts. Whether my package from Amazon gets to my porch today or next week, I feel like next week's probably going to be a better option for the environment and for lots of other reasons. But not really into all of that. But tractors, farming, that kind of stuff I'm really passionate about. So in 2016, I was on a trip out to so I was living in Boston at the time, came out on a trip to do some collaboration with some of the faculty at UC Davis. I was doing a USDA project, robotics project. And I thought, well, maybe I'll look around and see if there's any property available out here. I grew up in San Jose, so always wanted to get back to the West Coast. And I looked at probably every single property over 10 acres available in the Bay Area, and there weren't that many of them. And I came across this property in San Gregorio, and I just absolutely fell in love with it. It's so unique. I didn't find anything else like it. I wasn't actually planning on buying anything at the time, but I realized that if I didn't buy this property, I'd probably regret it for the rest of my life. And if you ever visit, you'll understand why, and you're all welcome to come. But one of the things I really love about it from a research point of view is its varied terrain, climates, and its location. It has given us the opportunity to test technology in sort of all the different situations and environments that you might want to test. It's just a lot of fun, really beautiful. We've got giant redwoods and ancient oak forests and rolling hills and fields and chickens and goats and orchards and row crops and all the different things. So one of the reasons I bought it was to help move the industry forward. Anyone is welcome to come out and test their technology there for free anytime. Our goal is, again, this idea of pre-competitive collaboration. How do we help people move forward? So some of the projects we're doing there. Farm Internet of Things. We've been, I got kind of frustrated as I started automating things around the farm that there were no good tools out there to do it. Like the sort of legitimate industrial strength ones were way, way, way too expensive and not particularly modular and useful. And then sort of the off-the-shelf stuff you could get from Amazon just really lacked, the sophistication necessary. So we said, all right, we'll build one from scratch. And the idea here, again, is we're trying to build this tool that then anyone can use worldwide to build these networks of sensing and controlling, complex machines. And in this case, the machine is the entire farm, the entire enterprise working together as one system. And it's pretty exciting what we've been able to do. Like with all of our projects, we're incredibly focused on ultra low cost, making everything so that even throughout the developing world, they can afford numerous quantities of each of these things. Using that on a project we call GoatBot. So we were thinking, you know, hey, it's a real pain to have to put up fences everywhere, but these goats are incredibly useful, and if we could actually just tell them where to go, where we want them to graze, how great would that be? So we built a little device that can actually guide the goats to go and graze in the right places at the right time, all sort of computer controlled. And this idea, again, of the entire farm as a system, right? The goats are part of that system, the sprinklers are part of that system, the tractors are part of that system, the water temperature sensors, the weather sensors, all part of that system. This is just a plug for, I don't know how many people here are engineers. I'm used to speaking to engineers, but one of the things I always encourage engineers to do is oftentimes you'll get sort of into a management or, you know, entrepreneurial side of things, and you sort of start losing connection with the engineering. And so this is a circuit I designed to control sprinkler solenoid valves on sprinklers because everything I found, again, was really expensive. And they didn't need to be that expensive. And, you know, we want to deploy hundreds, if not thousands of these things on a single farm. And that cost adds up pretty quickly. So I ended up figuring out how to control this sprinkler solenoid with basically with three transistors that all cost less than a penny a piece. Obviously, there's more than that in terms of the circuit board and all that. But I think it's really important to you know, be down in the weeds as an entrepreneur, and that's where a lot of the magic happens. I have this, remember what Joe Smith said, never hire anyone. It's just a story from my past. When I first started out, I was doing independent contracting, consulting for a company, and there was another consultant there working alongside me. I was doing some, it was in the medical field. I was actually sort of doing medical coding automation. I'm sort of, you know, an AI smart bot type of thing. Anyway, I said, hey, Joe, you ever think about hiring somebody and maybe starting to expand your operation? He was really funny. He said, whoa, 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 Daniel, stop, sit down. Let me talk to you. He looked me in the eye and he says, never hire anyone. And I'm like, well, what are you talking about, Joe? He's like, yeah, he says, as soon as you start hiring people, you change from being an engineer to being a manager. And being a manager isn't that fun. I didn't end up taking that advice, but again, it was something that I think it's really important to remember. You got to do what you love. And doing what you love, again, is where the magic happens. And being truly honest with yourself about what you're doing, whether what you're doing is something you love, can make all the difference in not just your career, but your total satisfaction in life as well, which has a big impact on your health. I should also mention mental health here because a lot of what I've focused on is trying to help normalize this idea of mental health. Our brains did not evolve for this. Our brains evolved to survive on the savannas of Africa. And we subject our brains to things that are just not healthy mentally for us. So, you know, there's sort of the stigma of either you're crazy or you're not, and we need to just all get that out of our heads. Just like we're all on the spectrum somewhere of physical health, we're all on the spectrum somewhere of mental health, and we need to do the things necessary to continually take care of and improve our mental health. So, side note plug for that, but very, very important. So on the farm, we have this high-speed network. You can't see them, but where those arrows are, way off in the distance, we've got these Wi-Fi network towers. And I had my children out to the farm for the summer, and my 14-year-old boy, I gave him an internship. His job was to deploy a robust high-speed wireless network across the entire farm. So he did a really great job with lots of motivation, obviously, because him, like most boys that age, just want to play video games all day long. And so we took some fallen redwoods and trimmed them down, basically made giant Christmas tree holders, put to solar panels and Wi-Fi repeaters and point-to-point Wi-Fi dishes. And so if you could see this, you'd see a little white dish off in the distance all pointing out. I'm taking this picture from the farmhouse. So we created a high-speed network that all comes from the farmhouse. The good news is that now we've got wireless across the entire 127-acre research farm, which makes running robots and all of this IoT technology actually be able to communicate. The cell signal out there is just not really good, and even if it was, cellular modems, running things on cellular modems is very expensive. So one of the other projects, we do this autonomous drone mapping. I had this idea when we bought the farm that wouldn't it be cool if we did a full 3D photorealistic map of the farm every week for 10 years, and then we're able to sort of play back or see the impact of our interventions, our spreading of compost or the different ways that we've interacted with the land. So that's a picture of our drone. And this is just sort of fly-through of that video. So you can see this is a full 3D model of the entire farm. It's really cool to even just look at this and then see, that was a fly-through from like 2 years ago, and just see how things change over time. Again, this idea of data and being data-driven and using data to make decisions, I think, is a really powerful thought. And again, I guess I'm going to have to escape out of this. Glasses. I need robot eyes at this point. Wear eye protection. Everybody, please wear eye protection. I was going on a hike with my son on the farm, and I pushed a tree branch out of the way, and there was another tree branch, I guess, stuck on it, and it went thunk. Basically ripped out my eye. It wasn't good. So yeah, eye protection important. The drone stuff is really cool. Our other project, I think our big project, is our open source farming rover project. We call it Acorn Precision Farming Rover, or PFR. So this was actually a USDA proposal that I wrote probably 15 years ago now. Interestingly, where the robot is this doesn't happen that often, but really looks almost exactly like what we proposed in that proposal 15 years ago. There's some really interesting things about this. So what we're trying to do is build this platform that anyone can then use and adapt to local farming needs. I would call this, by the way, similar to the FarmNG platform. I'd call it a low-energy farming platform, right? This isn't to do deep ripping or tilling so much as other activities. What we realized, we did this study during the research project on how to power it. And I had this crazy idea that, well, we don't want to use a diesel engine. The standard, of course, at the time for a lot of these type of robotics was becoming lithium battery packs and charging those batteries. This is sort of early days of Tesla time frame. But we said, you get into this thing of, I really hate batteries. Batteries are the next big environmental disaster, but we have such a fascination with batteries right now that we kind of are ignoring that. And I find it interesting that, all of our new appliances are all battery powered, and they only work for like a year, and then they break, and then you have to go buy a new one, and they all end up in the landfill. Right? It used to be that you'd buy a car or a piece of equipment, and you expect it to last for decades. So again, this is something that I think as a society, as a race, we really need to address this. So we looked and we said, hey, what if we didn't have any batteries on this platform? What if we used the energy straight from the solar panels into the motors? Really bad idea? It turns out that we found that we could get almost twice the work done, twice the amount of mechanical work done by not going through a cycle into and out of the batteries. And, well, what happens when it's cloudy? What happens at night? Well, the robot goes to sleep, just like we should. Well, maybe not when it's cloudy, but the idea is that, most farms are kind of dependent on solar radiation to function. That's how the plants grow. It turned out to just be this really beneficial cycle, because when we got rid of the batteries, well, then the motors didn't need to be as big, because you're not carrying around all this extra weight to power the motors. You oftentimes get into these engineering cycles where, well, I need more runtime, so I need more batteries, so it gets heavier, so I need bigger motors, which makes it heavier, so then I need bigger batteries, which makes it heavier, so then I need bigger motors. So we just stripped all that away. And it's really fun to just watch the robot out there sitting out in the field. The sun comes up, and then it just starts doing its work. And of course, now that we've developed it this way, you can easily add batteries if you want. You can easily add a small gas-powered generator to power it. But it makes it also incredibly low cost. In many of these systems, the batteries are the most expensive component of the whole system. And again, like I was saying, really an environmental disaster in the making. And how am I doing on time? When am I supposed to end? 10 more minutes? Perfect. Oh, I'm zoomed out still, sorry. So this is actually an older version of it, one of our first versions. But you see, it's a four-wheeled steering platform, so it can steer in any direction. Our farm's called Twisted Fields because we chose to actually make our rows follow the contours of the hills for a number of reasons. One, just because if everything was perfectly straight, we're not fully testing that our technology can work in any environment. Straight is obviously easier than curved. This was probably 3 years ago, and this robot just did hundreds of kilometers back and forth following these rows. We implemented what we call an RTK GPS network on the farm using incredibly low-cost components, sort of hobby-grade components. We're able to get centimeter-level GPS coordinates with using $30 GPS units. Again, this theme of how do we build things in an incredibly low-cost way that farmers in India or rural China or something can use. And part of the benefit here with making this so lightweight and low cost is that the whole platform we calculated at the time could theoretically be built by any shop in the world, motorcycle or bike shop that had basic tools for under like $4,000 for the entire platform. All of the compute is based on, again, off-the-shelf, hobby-level Raspberry Pi type of stuff, and it's just been a lot of fun to work on. So it's open source. Anyone can go on to our repository online, download all the mechanical plans, download all the software. As part of this, we were running into a problem where the motor controllers we were using were getting more and more expensive. They kept raising the price. That was becoming the most expensive part on the robot. So we said, look, I guess we'll just build our own. And we built now an open source motor controller that anyone can use that's really, really high performance, but the cost per unit is in the like the $20, $30 range versus the $500 a piece that the O drives we were using previously were costing. Next slide, all right. Okay, so that's kind of the very, very brief summary of what's going on at Twisted Fields. Again, just to reemphasize, we created this environment to help give the agriculture industry an environment where they could test technology. The whole reason I bought it was because I didn't want to be that kind of engineer that was trying to figure out how to automate something I didn't understand. And I'm sure you've all seen it, where there are, smart young whippersnappers coming out of school who've never farmed in their life, coming with all the solutions to your problems. And I've seen many, many times when people put a lot of effort into solving problems that don't exist or have already been solved, or they're not really familiar with the reality. I mean, like sometimes there's mud, sometimes there's rain, sometimes there's pests, and until you've driven a tractor, you don't really realize that it doesn't always go where you're steering it to go, right? Lots of things like that. So I always encourage my engineers to play. You've got to play. You've got to be out there playing with the real stuff, getting your hands dirty, doing it for real, learning how it's done conventionally before you try to automate things. Somebody had mentioned they'd like to hear just a little bit about what it's like to be an entrepreneur and funding startups and that type of thing. So just a couple of very brief slides. I just did a podcast on the Robot Report, and one of the things they talked about is that how if you don't have venture capital, people look down on you a lot of times in the startup world. Like, you're not legit if you haven't gone out and convinced a venture capital firm to give you some money. I wholly reject that idea. As a matter of fact, I'd say VC is probably one of the worst ways to build a company, and avoid it if you can. It can make sense in certain cases, but there are lots of other ways to do it. Some are listed here. I've used pretty much all of these in building my companies. I think the most important thing is to realize that you can do it. You have the expertise, the passion to do the thing that you want to do. Don't let anyone tell you that you can't, and you got to trust your gut. A lot of people out there that are going to give you, tell you things that might or might not be true. And I always, for years, I've been telling people that taking VC can be like pressing the self-destruct button on your spaceship. What's this from? Alien, yeah, exactly. So if you remember the movie, right, the alien gets on board, the VC maybe, I don't know, like presses the self-destruct, 1 hour time countdown, and then she's got to find the alien, kill the alien, and disable the self-destruct, or everything's getting blown to hell. And that's kind of what happens when you take VC. The statistics for VC are not great. Depending on who you believe or how you count, 1 out of 20 VC-funded companies is actually successful. 1 out of 20. And this, of course, flies in the face of sort of the idea that many people have of, oh, I got a VC to give me money, so I'm successful. Right? No, you're not successful. You convince someone to give you some money. Success is having an impact in the world. Success is making a difference. Success is changing the world for the better. So just some advice and lessons learned I've had over the years. And this is my last slide, so hopefully if there are questions, we can spend a couple minutes on that. As I was just saying, it's really important to try and avoid things that put an expiration date on your business. This is one of the problems sometimes with taking VC or other forms of cash in, because it creates an artificial timeline. And oftentimes the industry, the market might not be quite ready for it. It's always very easy to underestimate how long it's going to take to get technology to a point that it's truly providing an ROI. Personally, for me, I made a huge mistake where I gave up some control in one of my companies that I shouldn't have, and the investors basically screwed me over and took it away. Don't give up control. You won't get it back until you're really ready to emotionally let it go. No one else will care about your business like you will. Don't assume other people know more than you just because they speak with more confidence. Despite my impressive resume, which I don't really take a lot of credit for, I had a lot of opportunities that I'm grateful for. Most people didn't have the opportunities I have, which is one of the reasons I feel so strongly about giving back. But despite all that, I'd be in meetings with people and somebody would just be speaking with such certainty. I'm like, man, that person is really confident. They must really, really know what they're talking about. So, I'd listen to them, and I'd change what I was doing according to them. And what I realized is a lot of time I was sort of just being duped into doing something that somebody who was not necessarily that insightful on a topic was saying, just because they were saying it with more confidence. The key, of course, to successful business is take care of your team and your customers, and they'll take care of you. Sorry for the French, fire fast. I had a very strong no assholes rule in the company. Like, one bad apple really does spoil the barrel. It's really about creating an environment that the most talented people in the world would want to be a part of. And when there's drama, people start running for the doors real fast. So it was really hard for me to fire the person the first time years ago. I remember I agonized over it for about a month. You know, because I'm a very empathetic person. I really want to take care of people. I was like, it's okay, I'll mentor him, I'll coach him, I'll help him get better. And eventually realized that I was actually doing a disservice to everybody else in the company in that way. And my responsibility as CEO and founder was really to help that person be successful elsewhere as quickly and as effectively as possible. But it's a hard lesson to learn. Almost always, after you let that person go, you're like, wow, why didn't I do that a long time ago? So keep that in mind. Make sure you're doing what you love. Take your time. It's okay to go slow. Don't fall prey to the, someone else is going to beat us to it. There's plenty of time. More important that you do something right, that you do it well, and you do something that you love. And then, the final piece of advice is to ask for advice. And follow it every now and then. Don't always follow it. I was just having this conversation. I invest in a lot of companies now, and I mentor a number of CEOs and founders, and they're always like, but the investor said to do X, Y, and Z. And I'm like, they do not know your business. They are not the experts. They put some money in. They're not your boss. And back to this idea of people speaking with confidence. So I always recommend to people, I say, you should ask them for advice, but this is how you do it. You say, hey, I'd be interested to get your thoughts on something. I probably won't take your advice. Ultimately, I'm the CEO and I have to make the decision, but I'd really be interested to get your perspective. People love giving advice, but you're setting it clear right up front that their job isn't to tell you what to do, right? Their job is to provide information for you, and you're going to take all that information and you're going to process it in the context of all of the reality of day-to-day business and make a great decision about how to run the company. And then finally, we should all help others. Giving back, helping others, being open to sharing and collaborating, I think, is really the key to success. And I have gotten more from helping people than I've ever given others in that process. So thank you for the opportunity. I'd love to take any questions if we have time for that.
Thank you for that, Daniel. Really provocative and very intriguing, and appreciate you presenting all of that. I think we have time for a couple questions, probably two. I imagine the next panel will be able to have some further discussion on that, but if there's two questions that anyone would, we have one right here, Brad.
What was the question? How much time do I spend on the farm and?
If you live there, maybe.
I do live there.
Great.
Yeah, it's a little slice of paradise. Very, very peaceful. It's interesting, actually, because when I go, I have a home on the East Coast as well, in Boston. And when I get to Boston, I sleep pretty well the first night. Second night, maybe not as well. Third night, I'm starting to, have a little insomnia. Come back to the farm, sleep like a baby. Making sure that you're in an environment that's healthy, that you really enjoy, I think, is really important. And again, just being there and living it every day, I come across opportunities or needs for innovation that I would have never been exposed to had it been, me visiting a farm periodically. You really have to immerse yourself in it and live it to, I think, really see the opportunities to fundamentally change the world. Yeah, come up, check it out.
One more? We got one here. Hold on.
Yeah, so you can go on our website and sign up for a tour anytime. We've already hosted some groups from UC Santa Cruz up there. We have volunteer opportunities, but also just come and we've got a lot of veggies that, you know, honestly, we feed most of our crops to our chickens. Just amazing organic fruits and vegetables that, you know, I love it when people actually get the opportunity to eat them. We go to some farmers markets, but you know, anyone who's sold at farmers markets knows that you don't make much money there. So, all right, well, thank you very much, and certainly feel free to reach out anytime, and hope to have the opportunity to collaborate with all of you at some point.
Okay, that was great. Thank you, Daniel, for that. And hopefully you'll stick around so people can have conversations. As I said earlier, the great value of this conference has been the interaction among the participants. So